Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today. We've got garages with cars in them. Here's garage 1, here's garage 2, here's garage 3. Your challenge is to predict the number of cars in garage 4. Looks like it's going to have to be a pretty big garage. If you can do that, can you predict how many cars would be in the huge garage number 43? And can you write an equation that could be used to predict the number of cars in any garage at all? So that's the challenge. If you'd like to accept it, pause the video and see how far you can get. All right, let's see. This is an odd pattern here. It's hard to sort of make sense of it. It's kind of this sideways T, but then the bar of the T is getting thicker. The sides are getting longer. I think instead of trying to maybe see a pattern in this right now, I'm going to start by analyzing the numbers because this one is not immediately jumping out at me how to sort that out visually. So I'm going to start with the numbers. That's okay to do sometimes. So I'm going to make a chart with the step number and the number of cars. And in step 1, we've got 4. And in step 2, let's see, that's 6, 7, 8, 9, 10. And in step 3, we've got there's 12, 13, 14, 15, 16, 17, 18. Okay. So is there a pattern we can see here? Well, it looks like this is not going to be linear. And I know that because when I take the differences here, 10 minus 4 is 6, and 18 minus 10 is 8. So it's not the same. It's increasing. The amount that it's increasing increases as you go up. And it looks to me, this actually looks kind of familiar. 6, 8. So I'm wondering if we go up 2 more next time, that would follow this pattern of it's increasing the amount it's increasing by 2. So, sorry, instead of 2 here, I would want 10, right? And then the differences here, the second order differences would be 2 and 2. So 6, 8, 10. If I added 10 to 18, that would give me 28. So that would be a prediction for step 4. Now, that might seem a little shaky to you. We kind of went at this backwards. Let's see if this makes sense, this kind of a pattern here. What I notice is that, if this is right, if what I'm doing is right, then we get a constant in the difference of the differences. So that means it's a quadratic. So I think what I'm going to do is look for x squared in each step and see what's left over and see if that makes sense. So let me actually change the color here. So here's an x squared right there. And then here's an x squared, 2 by 2. Okay. And then here's an x squared right here, this 3 by 3. So what do we got left over? Well, let me switch back here. So here we've got 3 left over. So that's x squared and 3 more. And this is 1, 2, 3, 4, 5, 6. That's 6 left over. So x squared and 6. And here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Aha. So this number of what we have left over seems to be the step number multiplied by 3, right? Because 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9. So it looks like we have an x squared and then a 3 times the step number, a 3x. So just double checking that this makes sense. This for step 1, this would be 1 squared plus 3. Whoa, come on, pen. 3 times 1. And 1 squared times 3 plus 1 would be 4. So that looks good. How about for step 2? That would be 2 squared plus 3 times 2. And that's 4 plus 6 equals 10. Yeah, that's what we're getting. Let's see if that actually comes out with the same prediction we're getting in step 4 here. So if I put in 4 squared plus 3 times 4, that would be 16 plus 12, that would be 28 for step 4. So this looks like it's making sense, and it looks like we were right with this prediction by the numbers. So our equation here is y equals x squared plus 3x. And let's see, the next step we decided was 28, so I'll fill that in here. And how many in step 43? Well, we'll just plug 43 in for x here. So y equals 43 squared plus 3 times 43. And let's see, 43 squared is 1849, and 3 times 40 is 120, plus 3 times 3 is 929. and that would be 18 and a 7. So 1,978 cars in garage number 43. Well, how did that go for you? Did you get 28 for the next step? How did you arrive at it? Did you see some sort of visual pattern here that I didn't see? Let me know. Thanks, everybody.